Alright, it's time for the solutions for the function properties review paper. Your paper's blue, mine's a little bit wider than that. So what you need to do is first graph your function, and this guy's right here, and that's the function, or the function f of x equals negative x plus 2. Well, you can imagine that's just y equals negative x plus 2. If you have that, the number not with your x is your y-intercept, so you go to 2, and you're going to start right there. And the number with your x is your slope. Oh, there's no number there. The number there is 1, and it's negative, so we have a slope of negative 1 over 1. So we can go down 1, right 1, and we can get another point. And now we have 2 points connected up. And that second part was really hideous. And now we have a line. And we can get all these different behaviors about it. So on A and B, that's domain and range. C and D is x and y intercept. E and F are where it's positive and negative. G and H are where it's decreasing or increasing. I is the end behavior, and J is the asymptotes. Well, since this is a line, it actually doesn't have asymptotes. We'll get to which ones that do have asymptotes. I'll be those on the back with the exponentials. Right now for A, when you get the domain and range, well, my function goes left forever, and it goes right forever. And so my domain goes from negative infinity to positive infinity. And my function also goes up forever and down forever. And so my range, just kidding, B's right here, my range goes from negative infinity to infinity. C is your x-intercept, which is actually going to just be right there. That's the point 1, 0. D is your y-intercept. That's right there. Oh, wait, just kidding. That's not 1. Let me go back. This point right here is at 2, 0, because my tick marks are counting by 2 every time instead of just 1, which right here, my y-intercept is going to be at 0, 2. E and F are my intervals where it's positive and negative. Well, it switches right here at 2. To the left of this, my function is up above my x-axis, so that's where it's positive. And to the right, it's below my x-axis, so that's where it's negative. And so if you go from negative infinity to infinity, so you start at negative infinity, you travel, and you get to 2, that's where it's going to stop. So you're going to split this interval into 2 pieces. From negative infinity until 2, and from 2 onward is where it's going to be negative. So my interval where it's positive is negative infinity to 2, and the interval where it's negative is from 2 to positive infinity. G and H is trying to tell where it's increasing and decreasing. Well, you always travel from left to right. As you do that, does your graph ever go up? That answer is no. And so this one actually doesn't have an interval where it's increasing. But my function is going down everywhere, and so my interval where it's decreasing is from negative infinity to positive infinity. I is my end behavior, and I'm going to put that over here. And every time you do your end behavior, you're always going to start out with these phrases here. As x goes to negative infinity, your function approaches something, and then as x approaches positive infinity, your function does something, it approaches something else. That's going to be your other. You just fill in these 2 blanks, and you're good to go. Well, as we go left forever, my function keeps going up forever, and so if your function is going up forever, that's to positive infinity. And as your x goes to the right, as you travel right, your function is going down everywhere, and so your function approaches negative infinity. And that one's done. So this goes to I. And that brings us to 2. My line here, if you go to, since it is a line, there's no exponential part of this. It's just y equals something x plus or minus a number. So it's the equation of a line. The negative 4 gives me a starting point. That's my y-intercept. Oh, and while I'm talking about it, that's D, the point 0, negative 4. So before I even graph it, I can get that. And my slope is the number in front of x. That slope is 2/3. So then you go up to right 3. By the way, that's that far because we're counting by 2's each time. But really, since my tick marks everywhere are counting by 2's, I can go up to and write 3 and actually get another point that way. Either way is fine. Anyway, when you do that, you get your line, and it looks something like this. So now we have our line. We have to figure out what the domain and range are. Well, if you have a diagonal line, your domain is always going to go from negative infinity to infinity, and your range does the same thing. If you really want to puzzle that out, just think how far left and right it goes, how far up and down does it go. That's your domain range. C is your x-intercept. Well, it crosses right there, and that number is at 6. So my x-intercept is at 6, 0. Sorry. E and F are the intervals where it's positive and negative. Well, it switches right there at 6. To the left, my function is down below, so that's where it's negative. So from negative infinity to 6, my function is down below, as in it's negative there. And to the right, my function is up above my x-axis, so that's where it's positive. And so from 6 to infinity is where it's positive. G and H, where is it increasing and decreasing? Well, if you travel from left to right, your function is always going up, so it's always increasing. G is going to go from negative infinity to infinity, and H, it's not going to have any such interval or intervals. J actually doesn't exist. The asymptote, there is no line that this function gets really close to but doesn't cross. And I, my end behavior, it always starts out this way. As x approaches negative infinity, your function goes to some value, and as x approaches positive infinity, your function goes to some other number. For my left end behavior, when I go left, my function keeps going down and down and down, so my function goes to negative infinity. As you go right forever, your function keeps going up and up and up, and so my function goes to positive infinity, and that one's good to go. And this is just the I part. And that brings me to 3. Yeah, we're going to do 3. And let me get a little bit of more work room here. Okay, anyway, back to work. So we need to graph this. The number not with the x is your y-intercept if it's a linear function, which we have here. So that's going to be right there, halfway between the origin and 2. And we have a slope of 1/5, so you go up 1 and right 5. That gives you that point right there. And now we have 2 points, so we can draw a line just like so. So it's pretty level, but it is increasing as you move from left to right. And so that actually answers G. As you go from left to right, it's increasing everywhere. So H would be none. But anyway, let's do the first part now. Domain, how far left and right does it go? Well, it goes from negative infinity to infinity. And it goes down forever and up forever, so my range is from negative infinity to infinity. My x-intercept is going to be over here. If you remember, the slope is 1/5, so if I go down 1, left 5 is where my other point is. So my x-intercept is at the point -5, 0. D is my y-intercept. I already have that. That's the point 0, 1. It's in my function assignment there. He's asking where is it positive? Well, it switches right there at -5. To the left, it's negative, and to the right, it's positive, meaning above the x-axis. So from -5 to infinity, it's above my x-axis, and before that, from negative infinity to -5, it's below my x-axis, so that's where it's negative. For J, again, this one doesn't have an asymptote, so I'm just going to put none there. And then doing I, which is my end behavior, as x, okay, let me make it a little bit sorry. So as x approaches negative infinity, my function is going to, well, if we go left forever, my function goes down forever, so my function goes down to negative infinity. As I travel to the right, as x approach positive infinity, my function is going to be approaching what? Well, it'll go right forever. My function is going to go up forever. If you go up forever, that's positive infinity. So that's my end behavior that goes where I is. And that brings me to the last one on the front side, and we'll finish with this one. My function doesn't have a number that's not with the x, so my y-intercept is 0. So that's going to be actually the same thing as my x-intercept if it crosses right there at the origin. And my slope is -4 or -4 over 1, so I go down 4, right 1, and 1's only halfway across, by the way. So right here in between, we now have 2 points. It goes like so. It's pretty steep. It's decreasing. As in when you go left to right, it's decreasing everywhere. So that's actually h. From -infinity to infinity, my function is going down. Which means for g, there is no interval where it's increasing. Anyway, let's do a and b, domain and range. How far left and right does it go? Well, it goes all the way left and all the way right. It doesn't stop. And my function also goes down forever and up forever. So my range goes from -infinity to infinity. E is asking where is it positive? Well, it switches right here at the y-axis. To the left, it is up above. So that's from -infinity until I reach 0, right here. And it's positive from then, it's negative from then on. So from 0 to positive infinity. This one doesn't have an asymptote. And your end behavior would be as x approaches -infinity, as in when you go left forever, your function keeps going up and up and up, so your function approaches positive infinity. And as your x approaches positive infinity, as you go right forever, my function keeps going down and down and down and down, which would mean my function goes to -infinity, and that's my end behavior for all of it.